Hi, my name is Yunus. We are the Abelian Pi Society at the University of Bolton, and today we are going to do a little probability problem. I'm going to try to solve it. So the question is, a company has 4 electronic devices, A, B, C, and D, which operate independently. This is important. Each device has a probability of failure of 0.1. So all of them have the same probability of failure, which is 0.1. The system is arranged so that it will operate properly if at least one of A and B and at least one of C and D operate properly. And the question, what is the probability that the whole system operates properly? So first of all, I'm going to start with the question, yeah? What is the probability that the whole system operates properly? So the probability of the whole system operates properly, let's call it x, is equal. Here they say that the system is arranged so that it will operate properly if at least one of A and B and at least one of C and D. So, is probability of at least one of A and B and at least one of C and D. So this at least one of A and B operates properly, yeah? And at least one of C and D operates properly. So operate properly, yeah? Operates properly as well, yeah? So I think always when we are going, it's better to use this technique. If they ask us to calculate the probability of at least something, I always do that it is equal to 1 minus the probability of the opposite of what they are asking. So, like this one, this first one, yeah, that is, let's call it P AB, right? Not A times B, but AB, yeah? And the other one is CD. So I'm going like the PAB is equal 1 minus probability of, so what is the opposite of at least one of them is working? The opposite is none of them is working. That means not A and not B. That is like when they ask us to calculate the probability of at least one of A and B, you can do it this way, is equal to 1 minus the probability of the opposite, which is not A is not operating and B not operating. It's the same with the C and D, so PCD is equal to 1 minus probability of not C and not D. Why we do the 1 minus that? Because the probability of CD actually, like we can do this line before, probability of CD is the probability of C is working and D is working. Because they say at least we assume both, and then we take 1 minus the opposite, so C is minus C and D is minus D. So because the probability of C and D plus probability of not C and not D has to be 1. Okay, I take this out. Now all what we have to do is, because here we have and, we have to multiplicate them. So px is equal to 1 minus p not a
0.99, isn't it?
not a is
Nine.
not a is 0.1. A is not operating failure. No, the probability of failure is 0.1.
Yeah.
So that means probability of failure, all of them, not A is equal P not B is equal
Yeah,
P
yeah.
not, I just finished this quickly, but P not C, yeah, equal to 0.1. So 0.1 and 0.1. Yeah. It's the same because not C and not D is equal to not A and not B. So I just multiply it with 2, right? To be quicker. Because here we'll have a plus, right? No. Sorry, I did a mistake. So here there is an and. That means we must multiplicate it. And we must multiplicate. So multiplicate with the same. Yeah. 1 minus p 0.1 and 0.1. Check this off. So equal to 1 minus probability of that and that is that times that, yeah? So 0.1 times 0.1. And it's the same, so we just multiply it with the same, so square, which means like 1 minus 0.01 square, which is 0.999, yeah, square. Is the calculator? Is 0.9801. That is the answer. Thank you for watching. Please watch the other videos. Thanks.